picture yourself?
But like how? If he lives like across the world.
Okay.
Blackmail.
I really need to like flex on my one friend that I have a picture of this person. But like I'm stuck at persuasion.
I totally thought you were giving me a riddle.
No.
I mean, I low-key thought that you were giving me a riddle.
No.
I don't know. I myself am hesitant to give my picture to people.
Okay.
Especially online, because you don't know what they're going to do with it.
Okay. Thank you for your input.
Not very helpful, I'm afraid. Here's a little brain teaser for you guys while I'm just getting set up here. I'll show you what I was doing. I'll show you why I'm a little late joining the meeting. I just got caught up in these optical illusions. I'll show you in a second here. So if you think you know the answer to the brain teaser here, feel free to turn on your mic and let us know.
He's dead?
Nope. He is very much alive. Any other ideas?
Maybe because he was like dressed or, oh, never mind. I read it wrong.
Yeah.
Maybe since he bumped into him before, he might have met at a family reunion later on.
It's as though he has never met him.
He's a twin with
He
the
is
person's father?
Twin. Yes. Who? What? I can't tell who said that.
Bailey?
Bailey, nice work. So if your uncle was your dad's identical twin, you would definitely recognize him. So guys, here's why I was a little late joining the meet. Take a look at these optical illusions. Where did I put them? Oh, here they are. Look at this. Like it's a real photograph that was taken. And doesn't it look like a two-bodied woman? Like it's a wild looking picture actually. But that was not the one. This one, let me make it a little smaller. This one was really getting me. So there's a hidden picture in here somewhere and I do not see it. I need your help.
Is it some type of dragon or something?
I have no idea. Like, do you see a specific, like, I think whatever's hidden in there, when we see it, it will become very obvious. Does anybody see something in there that is a definite object? Goodness, I don't get that one. Okay, look at this one. So what color are the dots, you guys? Are the dots yellow or are they blue? Don't they look like they change? Right? If you kind of move your eyes around, sometimes they look yellow, you go back to the same one and suddenly it looks blue, kind of interesting. This one also kind of cool. When you look at the holes in these bolts, You know, those bolts look like they're perpendicular to each other. So how in the world would you get a little steel rod going through them if they were perpendicular? Kind of interesting, but here's another one. This one I can actually see. This one has a hidden. This one I can see, and now that I've seen it once, it's like I can't unsee it. Does anybody else see a hidden figure in this one? I'll give you time to kind of look at it before I point it out to you. Yeah, Ethan, I agree. Charlie, do you agree with that? Right in here, there is a Dalmatian dog in there. Do you guys see it? This is his or her head down at the ground and then legs here. Yeah, so Dalmatian dog. And once I see it, like I can't unsee it. It's just there every time, which is why this one is really bugging me. I try squinting, I try going farther back, closer up. I just can't figure it out.
There's a cow.
A cow?
Yep.
So try to describe to me like where the cow's face is. Tell me, I'll just circle and you tell me, should I go up or down or left or right?
I see the white part as the cow's face on the top left, kind of like middle left, right there.
That's a cow face?
That's what I see. There's like an ear, there's an eye, there's a nose.
Okay,
Oh, like
see the second dot to the bottom on the left.
this one?
No, to the left. That one's the nose. And then if you go up, that's the eye. No, up. Okay, go in the middle. Right, yeah, that one's the eye and it's facing down.
How many people can see a cow there? I still don't see it. That one's going to keep bugging me. Okay, let's see. I think there's another. Look at this one. So pretend you're a little person and you're walking on these stairs. What happens when you walk around this peculiar staircase? Are you going up or are you going down? Will you ever reach the top? That's crazy, hey? Okay, this one, you need a piece of white paper. Now, guys, I don't think I want, if you're kind of susceptible to headaches or anything from staring at the screen, you don't want to do this one. But here's the idea. I'll time you for people who, you know, you're not prone to migraines or epilepsy or anything like that, seizures. In this one, you're going to stare and focus right on that black dot for 30 seconds. And then when I tell you 30 seconds is up, you're going to stare very quickly, just stare at a blank white piece of paper. So get a white piece of paper ready to go. Okay, and I will start timing now. $30, go. Oh, I saw it. Did you guys see a pink heart? That's kind of cool. I found that you really had to stare at a spot on the white paper. So that was kind of neat. Okay, this one I think is very cool. So guys, see these lines that are going down the page? So the lines are the white and black. So we have these lines going down the page that have a white and black pattern to them. In between the lines, you've just got this gray space. And doesn't it look like those lines are kind of curved or that they're bending in the middle? They are actually all parallel. If you printed this out and held your ruler along each one of those lines, you'd see they are not curved. They are straight lines that are all parallel. Crazy, hey? The tricks that we can play on our eyes. Now, I didn't get to this one yet. What is this one? Can you find the 5-pointed star hidden in the pattern? Oh, found it. So perfectly symmetrical 5-pointed star. I'll let you guys keep looking, give you time to find it. How many people have found it? Give me a thumbs up. Yeah, so right in here, I'll trace it. This is the very top point. Okay, pretty cool. Okay, here's another one, optical illusion. Which red line is longer? Now, to me, it definitely looks like this one is longer. However, again, if we actually printed this on paper and used a ruler to measure, we'd see this line is actually longer than this one in the back. Sorry, we're getting way off track. You can see why I was a little like lost coming into class because I shouldn't have got caught up in this. Crazy. All right, let's get to business here, everybody. We are starting a brand new unit. And this is our outline. Like, look at this short little unit, hey? We're looking at hopefully about a 5-day, I guess with our unit assessment at the end, we're probably looking at a 6-day unit here. What you see there in red, that's kind of the way I think our timing's going to work out here. We will, of course, have interjected in there a check for understanding here or there, or online assignment or quiz, but we're looking at a pretty short little unit here. And you know what? This is probably one of my least favorite units because I find this is more like social studies than math. So maybe for some people, you're going to say, oh, this is my favorite because it's more like social studies than math. But it's important to understand, you guys, that statistics and probability really is mathematical. In fact, when you guys get to university, just about everybody in first year university has to do a statistics class, and it's all math. In 30-1 and 30-2, there is a unit on probability, and it's all math. But in grade 9, the stats and probability that we look at is more kind of background knowledge and looking at like why do we need to know about it and where in society is it important to understand. So it's not very mathy at the grade 9 level. Anyway, let's start, please, by numbering the pages in your booklet. because they did not get numbered before they went to the photocopier. So this page that we see right here on the front, let's call that page 1, just so we all are doing it the same way. So this page on my screen is page 1. The back of this page is page 2, and so forth, until you get to the very end. The last one that you number will be page 28.
I was gonna ask, because on the schedule it says Friday, but don't we not have school tomorrow?
We do have school tomorrow. You know what? I've had a few questions about that. You're about the 3rd or 4th student who's asked about that. Ava, can you tell me like where that's coming from?
Well, our gym teacher has like a gym schedule, and it says that we have tomorrow off.
I wonder if it's just for your gym class.
It's like a yearly schedule, so I'm not sure, but
Because we do have next Friday off. We do have the 21st off. I'm getting nervous now because it's only grade 9s that are asking, so now that explains why.
My mom also said that we had tomorrow off, and I don't know where she would have gotten it from.
Yeah, so guys, I just in case, I got out the May calendar here. I'm not sure how well that's showing up, but it shows that Friday, May 21st is a day off for students. And it doesn't say anything about tomorrow. So be prepared for classes tomorrow. All right, we start our notes on page 2, everybody. Now, this unit is lots of discussion. Not so much today. Today is the more mathy part. But it is a unit where we're going to discuss lots of you think this, but they think that. And so what I want you to do is just get used to turning your microphone on when you want to ask anything. Don't ask in the chat because it just kind of slows everything right down. Just feel free to speak up with your microphone. This first page, you can take a look at it, kind of explaining what we're going to be looking at, why it is important. So I'll give you a moment to read. So there is a lot of crossover here between something like social studies and math. It's probably the part of a social studies project or class that those teachers don't really like. The part of the math that the math teachers don't really like. Because when you're collecting information, like maybe a survey or a questionnaire even, it's always got some math behind it. Like what's the best way to collect the information? How are you going to calculate some meaning from the data that you collect? In fact, you know what, there is, what's it today, the 13th? Tuesday was a Canada Census Day. You might have seen your parents filling in an online census form about needs in the community. And a census that goes out in Canada, it's actually your legal obligation to fill it in. So they collect all this data, and then they have to look at the numbers and mathematically figure out what are they going to do with this data. So you've got all these keywords, very much like a social studies unit. These are the ones that we are going to focus on in lesson 1. So let's get started. Guys, we're going to just do a little bit of review here, working with fractions, decimals, and percents. Very old stuff. I think in order to make this kind of worthwhile, we're going to also look at some of our calculator skills that we haven't used in a while. Okay, so relating fractions, decimals, and percents. This hundredths chart represents one whole, 1 or 100%. The shaded part of this grid can be described in 3 ways. As a fraction, so 16 out of 100 squares are shaded, or we could say 16 hundredths is shaded. In decimal form, we could say 0.16 is shaded, or even better, 16 hundredths is shaded in. And as a percent, 16%. Now, does anybody see anything wrong with any of those 3 numbers? Fraction, decimal, or percent? I guess not so much wrong, but not really the way we would want to do it. Charlie B, what do you say?
Yeah, basically the fraction, because it's you have to simplify it.
Yeah, you might start out by saying 16 hundredths or 16 out of 100, but you're right. We wouldn't really want to leave it that way. I can divide top and bottom by 4 and say 4 out of 25. It's just that that doesn't make as much of a connection to that hundredths chart. All right, so our first little calculation we're going to do is how to go from a fraction to a percentage. Now, what they're trying to show you here, so this little part right here, isn't that the coolest, you guys? This little part that they're showing you isn't necessarily so straightforward because it's all filled in for you. So let me just show you step by step what's going on there. We're starting with a fraction, 3/4. And we want to end up, what are we doing here? Percentage, I think it was. Yes. We want to end up with a percentage. So manually, what we would do is we would rewrite this fraction. We still want it to be an equivalent fraction, but we'd write it as a fraction out of 100. So I would have to multiply the bottom by 25 to get that 100. If I do the same thing to the top, that ensures that I am getting an equal fraction. So they suggest that we start by rewriting it as a fraction where we have 100 as the denominator, and then 75 out of 100 is 75%. So that's what they're showing us on the page. But I don't necessarily want you guys to go through and do that manually. You can if you want to. But the problem with it is when we get to a fraction like this. Because now when we start working with, going from an 8 to a 100, well, it starts to be an issue and you start to use your calculator to do this. So rather than doing it manually and needing calculator backup, we could do this just by going 3 divided by 4 and then multiply that by 100. And that will give you the 75%. Okay, so we've seen this before. This is just a refresher. Let's take a look at writing a percent as a fraction. Okay, so again, I'll just show you what it is they're trying to show us on our page there. They started with a 12%, and we want to end up in fraction form. So the first thing that we do is we write that as, really, what does that mean? 12% means 12 out of 100. So there it is in fraction form. Now this is kind of like the one that Charlie B had recommended, is that we're not really supposed to leave a fraction this way. It should be written in simplest form. So we can divide by 4, and get to 3/25. Now, you've done this many, many, many times, but do you remember how to simplify a fraction on your calculator? So let's see if we remember how to do that. So if I was doing this with my calculator, I'd start the same way. I'd say, well, that's 12 over 100. Now my calculator will simplify the fraction for me. If I just go 12 ABC 100 equals. So everybody try it out on your calculator. This is the instructions for the recommended calculator, but you guys, if you have a different one, you might have to play around with it and see if you can remember how it works. It'll simplify it for you to get 3/25. Any questions there or calculator issues? Okay, and then our final one right down here, write a fraction as a decimal. Well, sometimes you just know it, right? 1/2, I just know that that's 0.5. But if I didn't know it, I would do 1, that's a little blurry, but 1 divided by 2, you guys know that, is equal to 0.5. So here's our first little practice time, everybody. Please go ahead and complete this check. And while you're doing it, I'm going to take attendance. Now, I want you to turn your microphone on when you hear your name and say something so that I know you are here. I want you to get used to turning that mic on and speaking up nice and clear. Ava A.
Here.
Kendall.
Here.
And Charlie B, I know you're here. Charlie C.
I'm here.
And Darielle, we already spoke. Maddie.
Here.
Holly.
Yep.
Annika. Annika, you here?
I think she's having Wi-Fi problems because she was here.
Yeah, I see in the chat that she was here. Thank you. Bason? Ava H is here. Katie.
I'm here.
Ty, I think you were talking about the cow before, right?
Pardon?
Oh, you are here? Well, I was
Yes.
was that you that found the cow face earlier, Ty? I was trying to guess.
Yeah, that was me.
That was you?
Yeah.
And Jerry.
I'm here.
Kaden.
Here.
Emma.
Here.
Brian.
Here.
Ethan's here, but let's hear your microphone, Ethan.
Here.
Sarah? Bailey, I've heard you. Bree,
Here.
Anna,
Here.
Jocelyn, Elena,
Here.
Killian,
Here.
and Alora.
Here.
Perfect. So guys, whenever you want to ask something or you want to volunteer an answer, you don't need to click on the raise hand. You don't have to go on the chat. We want like open discussion here. So just feel free to turn your microphone on and say what you need to, but then make sure you turn it off so we don't get a bunch of feedback. Okay, we'll give you 2 minutes here and then I'm going to ask you for your answers. All right, number 1, question A. Charlie C, what is 35 hundredths as a percentage?
35%.
Thank you. And by the way, guys, on these questions, it doesn't matter to me if you did this manually or if you did it on your calculator. So all I'm going to get from you is your final answer. Emma, what percentage is 2/5? Elena, can you help me out here? Elena, what did you get for B?
Sorry, my audio wasn't working.
Oh,
I got 40%.
thank you. I wonder if that's what happened to Emma too. C. Alora, what'd you get for C? Oh, Alora's just coming back.
Sorry, I pressed the wrong button. I got 15%.
Perfect, thank you. Okay, and writing a fraction as a decimal. Ethan, what'd you get for 2A?
0.17.
Perfect. And remember, we could also say 17 hundredths as well, but it's funny, right? When we say 17 hundredths, it really sounds like we're saying a fraction, doesn't it? Anna, how about B?
0.26.
Got it. And Holly, could you tell me C?
I got 0.375, but I don't know if you had to round it or not.
No. You know what? We want to leave it exactly as it is unless they tell us to round it off. Number 3. Brian, what would the numerator be here? Or Emma, we'll try you. Emma, for 3A, what did you have for the numerator? Might be having lots of tech issues there on your end, you guys. Annika, were you able to get back with us here? Annika, tell me what you got for 3A, please. Maddie, how about you?
27/100.
Thank you. And then for B, again, we're not worried about how you got there. We'll just go for the fraction in simplest form. Katie, what do you have here?
1/4.
You betcha. And for C, Darielle, what do you say for C?
I was just working on that one.
Okay, we'll wait for you. So if I was using my calculator on this guy, I would start by saying as a fraction, that's the same thing as 70 out of 100. And all I would do, calculator-wise, which is really probably where we need the review, I would type in 70 ABC 100, and that would give me the fraction in simplest form. Now, if we weren't here to kind of practice our calculator skills, it'd be kind of silly to put this in our calculator because we can just divide the top and bottom by 10 and say that this is 7/10. All right. So guys, one of the more important things about what we just did there was trying to get used to answering on our mic and talking with the mic. So we'll keep trying and keep working at that so we're comfortable with it. All right, guys, we're looking here at theoretical probability. Now, you might want to use a highlighter if you have a highlighter, or put it in a box. This is one of our pretty big topics. Theoretical probability is really the kind of probability we're used to talking about. So if we were, let's say, talking about the probability that it rains tomorrow, or the probability that, I don't know, that when I pick out a candy, it's going to be a blue candy. It's just the regular probability we talk about all the time. And right in here it says, usually we refer to theoretical probability as the probability. Now, the reason we write that in there is because some of the questions you're going to work on, it might just say, find the probability. Well, that means they're talking about theoretical probability. Now, theoretical probability, it's based on what should happen numerically. So it's based on numbers, and you look at the numbers, use those numbers to say what should happen. And it says the theoretical probability of an event occurring is. That looks kind of funny because it's got words instead of numbers. But guys, this represents a fraction. So almost like a little formula showing you how to set up your fraction when you're finding theoretical probability or plain old probability. Okay, so in our check, this is like our example section here. 20 marbles are placed in a bag. We've got 9 red, 2 green, 5 purple, and 4 yellow. So total of 20. You don't have to write that down. I write that down so that when I'm glancing back at the question to get numbers from the information, I don't accidentally pick up the wrong number. It says you take 1 marble from the bag without looking. So this is a random draw. What is the theoretical probability of picking a green marble? So that's what we're looking for. What's the probability that we pull out a green marble? Now, outcomes are all the things that could happen. So all the things that could happen, we could get a red, we could get a green, we could get purple, or we could get yellow. Favorable outcome, that's the one that we're looking for. So like if we were making a little bet here, like what color are you gonna get? What are the chances it'll be green? The thing we're looking for is green. So green is the favorable outcome. All right, there are 2 green marbles. Now, theoretical probability, going back up here, you guys, we're going to set this fraction up. Number of favorable outcomes on the numerator, so number of green marbles would be the numerator, over the total number of marbles. So we would start with our fraction being 2 out of 20. So right when I set up that fraction right there for probability, it just really is the portion. What portion of the marbles are green? 2 out of 20 marbles are green. Now that one has the kind of the closest connection to the marbles, but we do want to write that in simplest form. So it would be better when we give a final answer to say 1 out of 10. So what exactly does that mean? Well, it means if we tried this 10 times, so I've got this bag of marbles, and I'm going to randomly draw a marble and then put it back in the bag. But if I was to try that 10 times, based on these numbers, I probably will only get a green marble 1 out of those 10 times. Okay, let's go decimal form. So we always start with a fraction, but let's also put this in decimal form and percentage. So everybody go ahead, convert from a fraction to decimal and percentage. So our probability in decimal form would be 0.1. And as a percentage, 10%. Now, when we are talking about probability, we might be asked to answer in any of those 3 forms, but notice that we start with a fraction and then we convert it from there. Okay, so I want you to go ahead and try B. Same kind of thing. This time, looking at probability of picking a marble that is not red. So go ahead through this little thinking process. Let's see how we do. if we are thinking on the same lines here. So it says the favorable outcomes. So these are the ones that are not red. So favorable, the ones we're looking for, well, green, purple, yellow. So those would all be favorable selections. Add to find the total number. So 2 green plus 5 purple plus 4 yellow is 11. So there are 11 favorable outcomes. Now we're ready to do our probability. So favorable outcomes is 11 over total number of possible outcomes. There's 20 different marbles that could be chosen. 11 of them are favorable. Now 11 over 20, that is already in simplest form. Let's go decimal form as well. Kaden, can you give me the decimal form for this one?
Sorry, my internet was kicking me off. I couldn't see the screen. Decimal form would be 0.55.
Yep. Thank you. Yep. And then, baby, how about percentage? What would this be in percentage form?
55%.
You got it. So let's just take a look at these two. In part A, probability of choosing a green marble, 10%. And B, probability of choosing one that is not red is 55%. So the 55% means it is more likely to happen. All right, so experimental probability. We find our answers for experimental probability a little differently. And it says right in the opening, experimental probability is the likelihood that something occurs based on the results of an experiment. And the experimental probability of an event occurring is another fraction. So notice that there's no shortcut name for this. If the question says find the probability, it's talking about theoretical probability. If they want experimental probability, they will actually say find the experimental probability. Now, experimental probability, it's not just based on what should happen, it's based on what has happened. In other words, data has been collected. Data has been collected on what has happened, and based on what has happened in the past, we make our predictions on probability. So a good example would be you and your dad are watching hockey playoffs. Your team is playing his team, and you're going to bet the dishes on it. Who's going to have to do the dishes? Well, in your betting, if you're trying to choose the winning game, it would be smart to look back at what has happened in the past. Data has been collected on who won and were they at home or was it an away game, all kinds of data you could look back at to make that probability decision. So let's take a look. This is where data has been collected or an experiment has been done to get the data. So number one says a counter is randomly drawn from a bag of counters. Guys, these counters really just kind of means tokens. Here are the results of 25 draws. All right, so we see in the chart here different colors. So I guess that's what we're talking about. The counters are different colors. So we randomly drew from the bag and 25 times, and 7 out of 25 was red. 4 out of those 25 draws was blue. 11 times we chose a yellow, and 3 times we chose a green. What is the experimental probability of drawing a yellow counter? So it's just talking about what actually happened. So the number of times yellow was drawn was 11 times out of 25. So we're just talking about how many times it actually did happen. That becomes the probability. So there is an 11 out of 25 chance. Now what does that mean in decimal form? There's a 0.44 chance that we're going to draw a yellow counter. And percentage-wise, that's 44% probability. So remember what that actually means. To me, the fraction actually kind of has the most meaning. It tells me that if I drew a token 25 times, I did that little trial, that experiment 25 times, I would probably get yellow 11 out of 25 draws. All right, guys, I want you to give B a try. And Ethan, I think your microphone might be on right now.
Yeah, it keeps turning on for a second.
Thank you. And I'm looking for a volunteer on this one. It's a little different because of that or, blue or green. And I'm wondering like what you guys think we should do here. So if you think you have a pretty good idea, turn your mic on and let us know what you're thinking. Jocelyn, what do you think?
Like 7 out of 25 or like 28%.
So where did that 7 come from?
I just added the blue and green together.
Perfect. So if we add those two together, we find out that there are 7 favorable tokens in the bag. So Jocelyn said 7 out of 25. And then I think you gave me the decimal form or was it percentage? Which other one did you give me, Jocelyn?
I said 28%.
Okay. And so decimal form, 0.28. All right. Any questions there, especially about the difference, you guys, between theoretical probability and experimental probability? What should happen versus what did happen? So we're going to get into our assignment now, you guys. And like we said earlier, lesson 1's going to carry over to tomorrow. Your assignment is page 10 and 12. And when we take these assignments up, you guys, it'll be a little different than usual. I won't just put up the answer key, but it'll be more of, you know, you guys reading out your answers and eventually discussion building in our answers as well. So make sure you've got it all ready to share tomorrow.
It's just 10 and 12, not 10, 11, 12.
Yeah, just 10 and 12. All right, so grade 9s, take a look at the screen here. I pulled up the current calendar that is on our school website right now. Mine, I was worried maybe mine was a little bit old that I printed off. So we have school like normal tomorrow, so make sure you're going to all of your classes, except maybe not gym, if that's what your gym teacher said. That's really all we have for today, you guys. So you know what to do. Stay strong, be kind, and stay safe out there, everybody. See you tomorrow. Go out and get your shots, everybody.